Today's objective is I will be able to solve quadratic equations that involve imaginary solutions. Sometimes the graphs of quadratics look like this. So you have a parabola opening down and there are no x-intercepts. And then this, where the parabola is opening up this time, however, it's above the x-axis, so it's never going to cross, which means you have no x-intercepts. In these cases, you will be able to find, or you will be unable to find real solutions. Instead, your solutions will be imaginary. You will know that your solution is imaginary when you are solving and you have to take the square root of a negative number. So anytime you see the square root of a negative number, that means you're going to be dealing with an imaginary unit. The imaginary unit for I is equivalent to the square root of -1. I squared is actually I being the square root of -1. If you square that, a square and square root cancel each other out, so I squared is a -1. In example 1, we are going to practice simplifying square roots of negative numbers. We simplify these the same way we do all the other ones, where you're thinking about perfect squares other than one that you're trying to pull out. If I take a look here, if I have the square root of -2, the first thing I'm going to do is go ahead and rewrite it as the square root of 2i. So anytime you have the square root of a negative number, it's still the square root of that number, and you're pulling that square root of -1 out, which is equivalent to I. And then you would simplify the radical like normal. So 2 is not a perfect square. The only factors of 2 are 1 and 2, so no perfect squares other than 1, which actually means that's your answer. If you have something like this, though, where you have the square root of -4, so that's equivalent to the square root of 4i, you're essentially just pulling out that square root of -1 once again. The square root of 4 is the whole number 2, and I'm multiplying it by I, so the answer there is 2i. If you have something like part C, you have the square root of -75, we're going to pull out that I, and it's just the square root of 75 now that I'm thinking about. 75 does have a perfect square other than 1 in its list of factors, so I'm going to go ahead and rewrite that as the square root of 25 times 3. The square root of 25 is 5, the whole number. The square root of 3 does not simplify, and I am going to multiply it by that I still, so that would be my imaginary unit for that one. If you ever have a number out front, it's important you recognize this is multiplication, so it's 3 times the square root of 16i, since I had the square root of a negative number. And then you would simplify like normal. The square root of -16 is 4, so I have -3 times 4i. These two are like terms. I can multiply -3 and 4 to get -12, and I'm still multiplying by that I. I'm going to leave the try problems for you to attempt, and we're going to go ahead and move on to example 2. So in example 2, we're actually going to try solving. We're going to use methods from solving quadratics. That could be the square root property. We also could do the quadratic formula. Quadratic formula could solve any quadratic function, but for this example, it does say solve each equation by using the square root property. So that's what we're going to stick with for now. When you're doing the square root property, your first step is to isolate whatever is being raised to the power of 2. If I take a look here, x squared already by itself, that's perfect. So step 2 is to take the square root, and as a reminder, whenever you take the square root, you need plus or minus. So if I take the square root of each side here, that square and square root cancel, that gives me x equals plus or minus the square root of -81. Well, we just learned how to simplify negative roots. I would rewrite this as plus or minus the square root of 81i. I pulled out that square root of -1. And then I'll simplify that square root of 81 like I normally do. 81 is a perfect square of 9, so the answer is plus or minus 9. Let's take a look at the next one. Again, step 1 is to isolate whatever is being squared. So I'm going to go ahead, and order of operations does matter here. I must add 4 first, giving me negative 36x squared equals 4. Then, to get x squared by itself, I need to undo multiplication using division. So I'm going to divide each side. That gives me x squared equals negative 4 over 36. To undo the square, I'm going to take the square root of each side. That gives me x equals plus or minus the square root of negative 4 over 36. That gives me plus or minus, I'm going to have an imaginary unit. So I'm going to pull out that square root of negative 1, and then I'm going to simplify this radical like I normally would. So with this quotient, you just take the square root of each number. The square root of 4 is 2. The square root of 36 is 6. So I have 2 6i. But that could be simplified even further. 2 6 is 1/3. So I'm going to say plus or minus 1/3 I. Take a look at part C. Once again, you should always isolate whatever is being squared. So I'm going to subtract 10 from each side. That gives me negative 36. Then I need to undo the multiplication of 3 using division. So I have x squared equals negative 12. Now that I have it isolated, I can take the square root of each side, giving me x equals plus or minus the square root of negative 12, which is equivalent to plus or minus the square root of 12i. And you can simplify the square root of 12 because I'm able to think about a perfect square other than 1. The square root of 4 is 2. The square root of 3 does not simplify, so it's plus or minus 2 root 3i. If I take a look at this one, first I need to isolate what is being squared. I must move the 6 over, so that gives me 6 equals negative x minus 1 being squared. Now what's being squared is not by itself yet. I'm going to divide each term by negative 1. That gives me negative 6 equals x minus 1 being squared. I can undo what's being squared now by taking the square root. That gives me the square root of negative 6 equals, square root and square root cancel, I got x minus 1. To get x by itself, I would add 1 to each side. And I also need to simplify that square root of negative 6. So the square root of negative 6 becomes the square root of 6i plus 1 equals x. Now, for imaginary numbers, there is something called standard form. You should always write the real number first, the imaginary number second. Oops, and I just realized I forgot to put my plus or minus right away. So, if you ever have a combination of real and imaginary, you put the real number first, so 1 first, plus or minus the square root of 6i, so the imaginary part second. We're going to focus more in another video about that, so that's a little bit early of a concept. Next, we're going to go ahead, isolate what's being squared. That gives me x squared equals negative 5. Undo the square by taking the square root. That gives me x equals plus or minus the square root of negative 5, which you can pull out that square root of negative 1, giving you I. Square root of 5 does not simplify, so that's actually it. One last one. You divide each of these by negative 2. That gives me x squared equals negative 12. Take the square root of each side to get x by itself, so plus or minus the square root of 12i. I'm going to go ahead and do that because the square root of negative 12 is square root of 12i. And then we actually already simplified that up here. 4 times 3 is the pair that you would want to use, giving you plus or minus 2 root 3i. And I'll leave the try problems for you.